Phillipos has got a background that includes chemistry and a BTech in polymer technology from the Tshwane University of Technology. He completed an honours degree in engineering and technology management from University of Pretoria, and is working towards his PMP certification. He's currently doing his MSc in engineering management at the University of Pretoria, and his experience includes research and development of paints and coatings, analytical laboratory, and most of his experience comes from the chlor-alkali manufacturing, where he works as a process technologist looking after brine purification process in utilities. So, Phillipos, it's over to you.
Good day, everyone. I'm Phillipos Sebapu. I work at the NCP Chem. My presentation is part of my master's project, which is I've already presented on the last symposium presentation. This is the work that is needed at my work to support the current brine purification system. So we have identified some of the projects. Then we chose the continuous improvement project, which is Lean Six Sigma. But unfortunately, we continuously having some brine quality issues and the same operation and maintenance challenges that was experienced before. So then I look around and thought about what can I do better to improve and or support the project that is being put in place. So the introduction of my presentation is about the waste challenges which is experienced by the companies globally. So companies need improved operation strategies because of like their operation system changes every now and then. So this is about the chemical production company based in Cape Town Park, South Africa, NCP Chem, which is experiencing market deficit based on the high operation cost and late deliveries, including the unsatisfactory product qualities. So this project is about the support of Lean Six Sigma project at my work environment, as I've already said. So the Lean Six Sigma project is being completed, it's been in operation, but it's still lacking somewhere since we saw the very same challenges that we experienced before. So on the objectives is to provide the support and do improvement. Looking into the theoretical framework and on lean manufacturing, including traditional working practices, change management. On the change management, we're looking into standard operating procedure, laboratory analysis cycle, and how the work is being carried out to the plant and the lab. Because we found the discrepancies between laboratory and the plant. That's where we realized the challenges about the quality issues of brine, which is a critical our processing stream within the chemical production system. So if we don't really have a good quality brine, we're going to have continuous breakdown challenges within the operation system. And this affects our equipment, very sensitive equipment, highly cost to maintain. So on the methodology, we have adopted a positivism methodology, philosophy, used a mixed research method, and also focused group discussion. The purpose of focused group discussion is to gather and expect judgment based on different experience and different guidance. Because of like this include various departments from the maintenance side, operation, and also the technical side, which is mostly our R&D. So that's why we had this focused group discussion. Those group members, they really put a lot of input into this project, and they give us great ideas on how can we turn this around. So this is a simple schematic presentation of the system dynamics, which is where we do problem articulation with formula dynamic hypothesis, and then we do the simulation modeling, we test, then we do the policy evaluation. Because of like previous, our company has been old. On the previous policies and other methodologies, I can say, is the old methods. I can say they are outdated. So then we had to look into them and see how can we continuously improve them. Okay, on this methodology part is where I incorporated system dynamics with 5 phases of Lean Six Sigma, which is a DIMEC: define, measure, analyze, improve, and control. So each and every step, I apply system dynamics to see what can we do better to improve every single challenges on each and every step. Is where we do problem identification, which is mostly, in this case, is a brine. On the brine part, we normally receive a salt from our suppliers. That salt have a variation of minerals. I can say heavy minerals, which is calcium, magnesium, and other minerals which form part of the salt, iron. Those minerals, we need a limited amount of them to form part of the brine, I can say brine quality or pure brine. So these process streams, they are very sensitive and very critical because of like there is a inconsistency of reagent chemicals used to precipitate those minerals within the brine. So here is where the issues come from, because of like within the operator side, they've been guided to feed a certain amount of bags in a tank, mixed together and feed the reactors. But the challenge is that there is an overfeeding and underfeeding within this process. And if you overfeed, the other impurities still pass through to brine, to electrolyzers with brine. And if you underfeed, you find that you have a lot of heavy minerals within the brine purification system. That damages what we call our electrolyzers, which is a very sensitive equipment to maintain. So it even affects the maintenance cycle of electrolyzers. We have breakdown issues, challenges. That's where most of the waste come from. Because this waste, including the spare parts, we found that we have to fix the equipment before time, labor issues, and overall equipment in large. So that's where we do the most work. And on the measure part, we measure. I've measured a lot of the variables that can be controlled, and how can we control them? Because of those variables, they form critical part, especially on the metal in brine. So this variable here, we just use the different method, including the regression method, because we have a data from our previous project. And we do the analysis, looking into the results, looking into the behavior of the results. We look into the behavior of the result. It also tells us on what are the challenges after each and every batches that we get. We're looking into the certificate of analysis of each and every batch of delivered raw salt. And then is where we do the improvement part. On the improvement part, we're looking into the results of simulation and modeling that I've done. And then here on the control part is where I've been looking much more on how can we improve and control the whole brine purification system. This control part, it goes together with on the behavior of I can say operators, knowledge, technology that can we use or implement. Here are just few things that we have included in this research, because of like I was looking to the maintenance cost, equipment lifespan, brine quality, and labor cost. Those are the excluded variable, which is still form part of the critical part of in process streams. There's a casual loop diagrams that I've formulated here, looking into the profit, how each and every variables impact the profit. We're looking into the barium carbonate, which is one of the raw materials that we use to precipitate as a part of the reagent chemicals. So we look into they have a relationship, each and every variables here. We look into the production cost. It does have a production impact on the production cost of overfeeding and underfeeding. If we overfeed, it's still a cost to the company because of like, we should have control those raw materials. We look into the new technology that we've implemented into the place, the impact of brine towards the new technology, which is a brine purification system. And we look into the investment. What can we do better to do this based on investment path? And these are just maintenance cost, cleanup cost, environmental issues, brine quality, production volume. On the production volume and the sales, if we have brand quality challenges, it affects our production volume, it also affects our sales. So this caused the customer complaints because of we could not deliver product on time towards our customers. Here are on the result part is things that I've identified and put them in place. On the causes of waste, we look into maintenance cost, brand quality, frequent breakdowns, and labor cost. On the comment, we found that we have a lot of high maintenance cost, and we have a very poor brand quality. And breakdown is more about moderate, and labor cost is a high. Because of like on the breakdowns, it affects too much on the labor cost. And this also affects on the spare parts. The impacts of waste is production volume, delivery time, maintenance cost, and the profit, which is the challenge that we currently have. And on the improvement strategies, we look into improving on managing waste. I recommend that on improve maintenance strategies, improve on brand on quality plan, and review operation procedures or standard operation procedures. I've included a simple schematic of a modeling and simulation where I model each and every step and the quality challenges of that step. So in this modeling and simulation, I've identified a few areas where are the key concerns of the brand qualities. Then the areas that need a real attention from now. Here I've shared the results of each and every step that I've modeled and simulated, looking into variables. I changed the percentage and look into the lab results and also product and brand results. Because we do have you can say, in raw lab results, then we have a production results. Both production results and the lab results, sometimes they have a less of challenges based on the, I can say, training and educational background and understanding. That's where we found the difference on what can we do better. So on the conclusion side, I said the company have a limited strategy to maintain consistency on a good quality brine. So it's about overfeeding and underfeeding, and also the controls, including the errors of operators. So helping on making a better adjustment and review on standard operating procedures, and also do the running the experimental. It will also add value within the company, and also looking into what can we do better to have a consistency and have a good improvement. During my research, I've identified few things which are critical, which is, I can say, employees' attitude, culture within the organization, knowledge of the work they are doing, how critical the work they're performing, it can have towards the quality or towards the organization. It also play a very critical role. The recommendation part, I recommend on the training of operators. We have to review and improve standard operating procedures, and also laboratory cycle samples. Because of our cycle times also have an impact. I can say we have a 24-hour cycle times, but our reactor retention time is about 9 hours. So we normally pick up quality challenges while they're already fed on the electrolyzers. That's why it's supposed to be reviewed, and also have to improve on the capacity on the brine tanks, dissolvers, and reactors. Because of this will also impact the laboratory sample cycles times. If also adding on the technology part, we can add on online analyzers before we feed in the reagent chemicals, because this is where the challenge starts. Having no online analyzers, those guys on the operator level, they feed what they've been told. They feed based on the standard operating procedures. But we found out we have more or less metal in brine at that moment. So it also adds on the part of the waste. So on the future research, I recommend that we can model the behavior of operators, look into the educational background, and shift cycle hours. Also, if they are tired or they've been working for quite some time, there will be some shortcut within the addition of bags and doing the quality job. This forms part of my end of my presentation. I thank you.
Thank you, Phillipos. I think it's a real interesting problem that you're dealing with here. Any time delay in a process, the longer it gets, the more difficult it becomes to control. Is there anybody who's got a question for Phillipos? I don't see a hand.